For photosynthesis, plants need two things. They need water and carbon dioxide. So monitoring the CO2 levels in your grow room is important. And in this video, we're going to talk about how to make a CO2 sensor with this Arduino powered device. Now, Arduino is an open source electronics platform similar to something like a Raspberry Pi, but it has the CO2 sensors, so we can use it to not only monitor the CO2 generation, like you can see here, and know if we need to add more or less CO2, but it can also send this data over Wi-Fi so I can monitor my grow remotely. And the other nice thing is it has all the sensors needed for the room, such as temperature, humidity. It even has moisture sensors that you can use in the soil, so you know when it's time to water your plants. And I'm going to cover those sensors in future videos. This video is going to focus on building the CO2 sensor. So starting off, what hardware to buy? I decided to go with the Arduino from DF Robot. This is the DF Arduino Uno R3, and this one worked great. Of course, any Arduino should be fine. And for a shield, I got this LCD keypad shield, because this gives me a screen inside of my grow to look and see what the ppm is. Now, the LCD screen is not necessary. You can send that data over Wi-Fi. So I also got this shield, which I can use alternatively to the previous one. And it, of course, doesn't have any light on it or anything. And you could use Wi-Fi to send this data over to your computer or to your web server or cell phone, whatever you want. So you will see me use this in the video, but really all I'm doing is using the digital pins here, and those digital pins are of course available on the LCD shield. And as far as what CO2 sensor to use, I went with this one. They do have multiple CO2 sensors. You can see here there's 3 different ones, but I only need the 0 to 5,000 ppm range, and this one has about a 5-year lifespan on it. So I went ahead and went with this CO2 sensor. Now, accessories that you may need to purchase are a USB cable to match your Arduino, as well as a power supply to match your Arduino. And just the regular 9-volt power supply is fine. Okay, so here is the Arduino board itself. And then I'm going to get the shield, and the shield lines up perfectly with the Arduino board. It has the pins on the bottom to line up. And the purpose of the shield is to protect the Arduino board from me making some kind of stupid mistake and then frying this Arduino board. That's the purpose of this shield, to keep that board safe. Okay, so I'm going to use the LCD shield instead of the other one, and that just lines up and snaps right in. And the CO2 sensor, and I have this wire soldered in. Don't worry about that for now. I'm going to talk about that later. Well, we want to connect the CO2 sensor to these analog pins. Now, this LCD shield uses the A0 pin for the buttons. So these buttons over here are using that A0 pin. You cannot use the A0 pin. So we're going to connect it into A1. Don't put it in A0, move it up 1 and put it into A1. Alright, now that the sensor is connected to A1, we're ready to connect the computer to the USB port. So go ahead and plug that into your computer. Alright, so I've gone ahead and plugged that into the USB of my computer here, and I believe the driver is working fine. But if you have any problems, go to Manage, or it'll find your way to Device Manager anyways. And in Device Manager, it should be under Ports. And you can see it here, the Arduino Uno on COM4. Right click and do an on install. Unplug it from USB first. So I'm going to unplug that. And then I'm going to do an on install. And plug it back in. Okay, so once you've plugged it back in there, you'll see that it installed the driver, and now the driver's ready to use. You might need to go through this process if you're switching between the two shields. The next thing you're going to need is the Arduino IDE. And the IDE, of course, is available at Arduino's official website. So go ahead and go here and download it. and install the Arduino IDE. You'll see I have it right here, and you just need to start off with a new script. So I'm going to click new, and here we are. We've got a brand new script that is going to run on the Arduino device. So over here at the DF Robot wiki page for the O2 sensor, they have a small tutorial, but you'll need to copy this code and put it into your script. Okay, I've pasted this in, and we can see by looking through the code that what it's going to do is go ahead and print the PPM to the serial console. So I'm going to go ahead and click upload, and I'm going to need to save it. Okay, now that I saved the file, I can go ahead and click here to upload, and it's going to upload this code to the Arduino. Now, if you have any problems here and it hangs or it gives you any errors, go back to the driver section and reinstall your driver, and because you can have problems when switching between the shields, for example. So now that I'm done uploading, we can go ahead and go to Tools, Serial Monitor, and we can see that every 100 milliseconds it's printing the PPM. Now you're going to notice, first of all, that I don't need it every 10 times a second. Once per second is fine, so I'm going to re-upload that, and let's go ahead and look at the serial monitor. And you're going to notice that the PPM is ridiculous. It's 14.35937. The reason why is because it's returning 5 volts on the analog signal. So if you see 14.359 on your PPM, what you've probably done is forgot to change the code to the proper input. Now remember, this device cannot use A0, it has to use something else, and we plugged it into A1. So the first thing we need to do is modify the code to say the sensor in is on A1, and I'm going to upload again, and let's take a look at the serial monitor. And you're going to see some crazy numbers here, and this is normal because it takes a little while when it first boots up to get calibrated and start working correctly. And you'll notice that it's dropping very quickly. However, I had a very high PPM readings when I first got the device, and I had to let it run in outside air for 36 hours before it got down to 400 ppm. Now they advised 24, but I had to go a full 36 hours taking these readings once per second. So if you plug your device in and you're getting PPM readings that are way too high, I'm going to cover that shortly. But first, let's get this PPM reading onto the LCD screen. Now, in order to print to the LCD screen, we're going to need to use the Arduino Liquid Crystal library. So the first thing we're going to need to do is do this hashtag include liquidcrystal.h, and that goes at the very top of your script. The next thing we're going to need to do is instantiate a variable of the type liquid crystal, and the parameters here respond to pins. You can look at the documentation for the DF Robot LCD display, but what we need to do here is define a new variable. Its type, of course, is a liquid crystal, and we'll just call it LCD. Now, again, the parameters it takes respond to pins, and for this DF Robot LCD screen, it's 894567. So the next thing is, in the setup, we're going to need to do the begin, call the begin function. And begin needs the number of columns and the number of rows. So we're going to do lcd.begin, and we're going to do 16 columns. Now 2 rows will let you use both lines on the LCD screen. Because I'm just displaying one number, we could just do 1 row. And now we're ready to print something to the LCD screen. But first we need to set the position of the cursor. And we could use set cursor, but I'm going to go ahead and just use the home function right here. So that's going to bring the cursor in the upper left hand corner. So I'm going to do lcd.home. And now we're going to do lcd.print. And I'm going to go ahead and print the concentration. And then right after that, I'm going to do a ppm. All right. Now I'm going to go ahead and upload this to the device. We can take a quick peek at the serial monitor to see if what kind of readings we're seeing. And of course it starts way high and it's bringing its way down. Let's look at the LCD screen. All right, so it's kind of working. It's showing the ppm on the LCD screen, but the LCD that's way too high. And I had the same problem. It was showing a ppm between 800 and 1600. So I had to go ahead and put this sensor out the window and get it in the fresh air for 36 hours. On the product page for the CO2 sensor, down to the very bottom under the discussion, I found some useful information, and I found out that I can calibrate the sensor by running it in fresh air for 24 hours. And in addition to that, you can do a manual calibration by putting the sensor in an environment that's at 400 ppm for 20 minutes and then connect pin 8 and 20 to ground for 7 seconds. So pin 8 and pin 20 need to be connected to ground for 7 seconds if the sensor is in air that's at 400 ppm. This is going to calibrate the sensor to the 400 ppm baseline, which it should be right at around 400 ppm outside. So it turns out the sensor automatically recalibrates itself every 24 hours back down to the 400 ppm baseline. And that if you run it in an environment for 24 hours continuously in an atmosphere of 800 ppm, that it will recalibrate and assume that the value is 400 ppm. And this is a problem because in the grow room, it's going to be up to 800 or maybe even 11 or 1200 ppm in a budding stage, and we can't have it resetting itself back to 400. But there is a way to disable the automatic calibration that happens every 24 hours. And we just need to use the serial tool to send a command over to it. The information on that is right here. I'm going to get into this later. So it seems like the definitive first step for this CO2 sensor when you receive it is to put it outside for 24 to 48 hours. I did 36, and after 36 hours, I was getting a consistent reading of 450 ppm, which 450 is too high for outside. It's 400 outside, so I needed to go ahead and do a manual calibration at this point. All right, so here's the pinout, and we can see that pins 8 and 20 HD for 0 calibration, and you need to put them to ground for 7 seconds for 0 calibration. That's what this means. And you can see I circled pins 8 and pin 20. Those need to be grounded for 7 seconds. How you achieve that, I'm not sure. Here's what I did. I went ahead and used a safety pin, stuck it under pin 20. That goes to a wire that is plugged into ground on the Arduino board. And there's another ground that I connected to this clip that goes to this tester, little current tester here. And then I just press this onto pin number 8. So there's probably a lot better way to do this, but this is what I had, and I was able to successfully do a reset by holding this together for 7 seconds. And that is how I finally got the sensor to 400 ppm. But there seems to be a lot of noise on this analog interface, and so the readings that are coming out from it they kind of spike and they jump all around. Plus 50, minus 50 ppm, and it's just because of the noise on the analog interface. That doesn't have anything to do with the CO2 sensor itself. So to fix that, it looks like you could switch from the analog over to the digital interface, and that eliminates the noise coming over that analog channel. And this does require soldering 2 wires to the transmit and receive pins here. However, I need to disable the 24-hour automatic calibration. And in order to do that, you have to solder these anyways. So there's two advantages to using the transmit and receive pins here. One is it's required because we need to send the command over to disable the automatic calibration. And it's also useful because we can switch from the analog interface, which has too much noise, over to the digital interface, which gives us a more accurate reading. And they need to hook up to the digital interface on your shield. And so that is right here. It's the green line. This is the positive, negative, and the green is the data line for the D is digital, and the blue one down here is the analog. So on the LCD shield, the digital is up here, the analog's down here, of course, and the digital you can see D0, 1, 2, 3, 11, 12, and 13. So what we want to do is hook up the digital. We need to be able to hook up 0 and 1, as well as probably some of these 12 and 13 or 11 and 12. So what we need to do is connect these two pins to these ones over here. And now I decided to use this little PC speaker wire to do it because I just had it in my computer box, and it also plugs in nicely right here. These two pins got to plug into 0 and 1, so they need to be right next to each other. So if you lift up that little plastic tab, you can pull that wire free. It helps if you push the wire forward and then pull up the plastic tab. It'll slide right out, and you can slide it into place so the two wires are right next to each other. And go ahead and get those wires stripped, and then you have a nice pin that will plug right into 0 and 1 on the digital interface. Alright, so now we're ready to get the soldering done. You just need to solder these two wires to the two far left pins. Those are 13 and 18. Let's take a look at the wiring diagram. You can see on the left hand side where the LCD screen shield is at that the D0 and D1 pins are the digital transmit and receive. Those need to go to the 13 and 18 transmit and receive pins on the CO2 sensor. So the receive on the shield needs to go to the transmit on the sensor, and the transmit on the shield needs to go to the receive on the sensor. And for reference, I'm just going to show the schematic real quick so that you could see that pins 13 and 18 are the UART, TTL, receive, and transmit. Okay, I'm ready to hook up the sensor to the digital interface now, but that's only going to bring the data through. I still need to get some power, 5 volts of power to the sensor. So I'm going to bring the 5 volts of power through this analog wire, and I'm pretty sure this is unnecessary, but I want to remove the blue wire because that's carrying the analog signal, and there's no need for an analog signal anymore because it's coming through digital. So I pull out the blue wire there and just going to plug in the red and the black into A1. That's just going to bring power to the sensor, but the actual data connection is now going to be going into the digital interface. But which ones? Well, that depends up to your code. We have to use 0 and 1 to send a command to program the sensor, but for just getting the data over, we could use any of the other pins we want. I'm going to use pins 11 and 12, and so that's where these two wires, of course, are going to go. Alright, so now I have the sensor hooked up via the digital interface and it's powered over here with the analog. Let's plug into USB. Okay, now this is going to use a totally different way of getting the CO2 concentration, so just go ahead and make a new script, and we're going to write a whole new script for this using the digital interface. And that is the same code that the other CO2 sensor uses. So go over to this page for the infrared CO2 sensor and go ahead and grab the code here for that sensor. We're going to paste it into a new script here. And we can see off the bat that where the receive and transmit pins are defined, and here they are defined as 10 and 11. Now be careful not to get these flipped around. If you do, they're not going to work, but the two pins that I used were 12 and 11. So I'm going to go ahead and save this script. Now let's go to Tools and Serial Monitor, and this says the board's not available. So unplug USB, plug USB back in, and we'll try it again. Upload. Okay, done uploading. Open up the serial monitor. And there we go, CO2 concentration. So anyways, it is working. We need to modify the script so that it also works with our LCD screen. Luckily, we have another script that already works with that. So we just need to go ahead and copy over the code for the LCD screen. We need to include liquidcrystal.h. We're going to define the liquid crystal LCD. We need to do an LCD.begin in the setup function. And then we're going to need to just print that LCD, it's the CO2, to the LCD. And fix a couple of these brackets while you're at it. And it's not concentration here, it's actually called CO2, so I'm going to replace concentration with CO2. And that should do it. I'm going to hit upload. And let's take a look at the LCD screen. Okay, so I had to put it out the window for about 20 minutes here. But it does now have a correct reading of about 400 ppm. And when I move this into my grow room, it of course goes right up to whatever the ppm is inside of the grow room. So the last thing we need to do is disable the automatic 24-hour automatic configuration. Alright, I've typed up the information here for how to enable or disable the automatic calibration feature. And let me describe how to do it. You have to send this hex code over the serial connection, and you need to connect the transmit and receive of the sensor to the transmit and receive of the Arduino. Now luckily we've already done this because we've already soldered those transmit and receive pins on our sensor. We just need to hook that up to the transmit and receive of the Arduino. And what that's talking about is this is the image of the Arduino board, and the transmit and receive you can see are up here by the digital interface, and the receive is 0 and the transmit's 1. Now we don't have access to these two pins because we have a shield sitting on top of it, but luckily our shield gives us access to that. You can see that with the shield, the pin out for the digital pins, the receive is D0 and the transmit is D1, and so you can see the receive is 0 and the transmit is 1. Everything's the same. Now on the LCD, it's the same case. We got the D0, which is the receive, and the D1, which is transmit. Okay, so I'm going to go ahead and unplug the USB, shut it down. I use this little twist tie on here when I hang it out the window so that there's no stress being put onto the wires themselves. But in this case, I need to move it down here. So the top one, which is black, is the transmit, and the red one on the bottom, that is the receive. So the transmit of the sensor needs to go to the receive of the Arduino, and the receive needs to go to the transmit. So you should be able to see that the D0, which is receive for the Arduino, goes to the black wire, which goes to the transmit on the sensor, and the D1, which is the transmit on the Arduino, goes to the red wire, which is the receive on the sensor. I'm going to plug it into USB. Alright, so it's plugged in and I should be able to open up the serial monitor. We won't see anything because it's no longer connected to pins 11 and 12. So this script isn't going to work. However, if we go to serial plotter, which we can't do that if the serial monitor is open, so close serial monitor and open up serial plotter. Now we have serial plotter. This is where we're going to send a command with. So I'm going to go back here. This is the command to enable automatic calibration every 24 hours, which means it's going to reset itself to 400 ppm every 24 hours. And this is the command to disable it. So I'm going to copy this and come over here. We need to make sure that we're at 9600 baud. And these options aren't applicable in this program because they're already input, but if you need them, it's 8-bit one-stop non-parity. And I'm going to paste that command in. The difference between the two commands is right here. This was for enable and this 0 right here is for disable. So I'm going ahead and put in disable, and I can verify that by looking at the after the 79. It should be a 0x00, and I'm going to hit send. Now there's no feedback here, but if you followed this and it's hooked up correctly, you will disable the automatic calibration. Now because we have this shield, I don't think there's any harm flipping these pins so that you reverse the transmit and receive. So it's going to 0 and 1. So I've gone ahead and flipped those. I'm going to plug it back in. So now transmit's going to transmit and receive's going to receive. So I'm going to try to open up the serial monitor. And of course nothing's coming through because it's only hooked up to 0 and 1. And I will open up the serial plotter. And one more time I'm going to take the disable command and try to send that through. Now I believe what's going to happen right there is it's just going to come through as gibberish, so it doesn't, it's not going to do anything. But I've tried to send the command through both ways, so just to ensure that no matter what, that automatic calibration feature is definitely turned off. And that's where this lengthy video comes to an end, because now we have a fully functional CO2 monitor for our grow room, which does not reset itself every 24 hours back to 400 ppm. And we can actually do a lot of really cool stuff with it, like send us text messages if it gets too high or too low. And in the coming videos, we're going to be talking about how to set up the temperature sensor, humidity sensor, as well as the moisture sensor for the soil, so we know when to water our plants. Might even talk about CO2 generation, and I'm trying some alternative methods, such as using chalk rocks with sulfuric acid, and just some different ways maybe to make some better, more cleaner CO2. But thank you for watching this video. I hope it has been helpful for you. I know I wasn't happy with any of the CO2 monitors on Amazon, and I wanted to have my own.